Hello and welcome back to the lecture on applied econometrics. So, in the previous lecture, we spoke about the difference between probability distribution and frequency distribution. In this lecture, we are going to see that in details, and we are going to see something very important concept that I sort of spoke few times is the double structure of variable. We are going to come to that concept, but before we talk about all these things, let us actually do an exercise, okay, and let us try to sort of forget about all these theories. Let us just try to see from the number and try to interpret things. Okay. So, let us say we are actually trying to do a problem, one of the very interesting problem in economics, and that is, let us say, the participation of females in the labor force. And you will know that in India, this is India is exceptionally different vis-a-vis other countries, because here the participation of female in the labor force is really low. And you can read about it. It's like as good as the number of entire population of Brazil. I mean, if the female population participated in the labor force, then another country like Brazil would have been in the workforce in India itself. So, they are like a huge number of people are not in the labor force, not in the workforce. Now, let us say you try to understand, you try to get some insight about why the participation of labor force is so low in India, okay? And how you do that? You, as an economist, you try to have some idea about like some variables which might be influencing it, and you try to get data, of course. From data, you try to sort of interpret results, okay? So, let us say I deploy a survey team, we really do not have data, and the survey team has collected some data from a district, let us say a sample survey, they have collected data, okay? And let us say they are collecting data on these two variables. One variable is that I, as an economist, I told them that you need to collect data on their family income, and I want to see how female workforce participation is actually changing with family income, okay? And that is a pretty sort of interesting question. And let us say I get these results, I will actually create a fictitious sort of number and number, and let us say I have this family income, and let us say I have 100, I have let us say 500, I have let us say 1000, then I have 2000, and this is this is weekly income, let us say. So, 100 rupees a week means very low for a family. Some families might earn 2000 rupees, let us say some families are earning 20,000 rupees a week, some families are earning 50,000 rupees a week, some families are earning 75,000 rupees a week, some are earning let us say 1 lakh rupees a week, some might be earning 5 lakh rupees a week, they are pretty rich. Some families might be earning 10 lakh rupees a week. I hope my zeros are correct. Now, this is the family incomes, okay, and you sort of get the sort of like number of females. So, you sort of create some ratio in that family, the adult females who can participate in the workforce, and how many of them are actually participating in the workforce. And let us say you got this number, the actual numbers, okay. You got the actual numbers. Let me write down here, actual participation. You get something like, say here it is 0.5, here let us say it is 0.38, let us say it is 0.34, here it is 0.3, oops, sorry, 0.31 or 0.3, here let us say it is 0.28 or 0.25, here you 0.25, 0.25, here you have say 0.21, here you see suddenly it has spiked up, let us say 0.75, here you see something like 0.79, here you see let us say 0.82, here you see 0.83. So, let us say these are the numbers I got, okay. So, this I just got these numbers from my mind, okay. Now, these numbers are not without any basis, okay. So, you can actually see this kind of number, and I will explain why these numbers would make sense. So, you see when the family income is really low, like 100 rupees a week, you actually see the actual participation is 0.5. Then as the income is increasing, you see the participation is decreasing, and it is happening till your earning is, let us say, 50,000 rupees a week, and then suddenly it is increasing when your earning is becoming 75,000 rupees a week, okay, and then it keeps on increasing. Now, there is an explanation behind it. So, it's sort of if you see, it's sort of an U curve, okay. So, if I actually draw this, so it will look like, let us say I have workforce participation rate, and here I have family income, and if I plot these two, what I see is something like this. So, the workforce participation rate is, let us say, like this. So, here it is 0.5 and here it is a 0.8, and there is a theory behind it. I mean, why we may see something like this in India, and that is because when we have the income of a family is very low, the females need to participate in the workforce, because then they need to sort of add to their family income, because the family income is very low. So, if I have weekly 100 rupees income, so perhaps it is a good idea for the females to actually work, because that will actually add up to the total income. Now, it keeps on decreasing, because as and when your family income is increasing, so your family members think perhaps that females, the female folks in the household, they do not need to do outside work, they can just stay back in the home, they can do their work, whatever household work, but they do not really need to go out and do the do the income. Now, when it keeps on increasing, it happens that usually the families which are economically well off, they are also educationally somehow they are probably living in the city, they have better education, and they probably do not have much of social taboo towards letting female to work, right. And here this phenomenon actually, it is from a research paper, and when females actually, the phenomenon is sort of U curve we see, because of the social taboo, when my family income is increasing, so I usually try the female folk in the house, not I do not really want them to work, because it to a family it might appear that if the females are staying back in home, so that is actually good, okay. So, because females going out and working does not give a good signal for the household, because probably men folks are not working, the family is really not, family is deprived or something. So, that is the reason usually the females are not, it is not a very common practice for females to work, and that is why as and when your income is increasing, you see this kind of trend where your female participation in the workforce is decreasing, but here your family income, with the increase in family income, and possibly with the increase in with a better education in this, or probably because of the fact that you are living in the city, what is happening is you are more liberal to allow females to work, okay, or females are also educated enough to actually or to make their own decision to work, right. And that is the reason we can see this kind of picture, and we can actually see this kind of numbers. So, that is the economics part. So, we are not really dealing a lot of economics here, we are rather more interested to look at the data and then go back to the definitions that we have been talking about. So, let us go back to the table. Now, I have seen that, I have seen the actual participation. Now, as an economist, your job is to model the things, okay. From observation you want to model, okay. Now, how do I model that? Now, I am going to actually write a formula, and that formula is, let me write down, let us say I am basically trying to create a relationship between family income and actual female labor force participation, and I am just writing it down first. So, this is 1 by log base 10, I provide this number here, and that is the probability of female workforce participation, and I will explain that. So, let us see the numbers as I go down up to 50, let us say. This is the function, it is sort of following, okay. Now, here I change the functional form. So, you see the numbers are pretty consistent here, almost same. Now, the second function I define 1 by log 10, the same 10 base with this number, and I see the numbers are 0.79, 0.8, 0.82, oops, and here I see 0.83. Okay, so you can see both the tables are actually, sort of both the columns are actually representing the same number. So, of course, I actually did it before, and that is why I know what the numbers are going to be, and that is why I have sort of did a back calculation when I put the actual participation. No magic here. So, the thing is on the third column where I see these numbers, where I actually plotted these this mathematical form, and let me actually write it down how I have written down the mathematical form. So, basically, so let us say probability of workforce participation rate is 1 by log say x base 10 when x is less than equal to 50k, okay, and it is equal to 1 minus 1 by log base 10 x when x is above 50k. Okay. So, this is the functional form I defined to explain the workforce participation rate. Now, what have I done here? So, what have I done here is that I actually got the actual numbers from, so I actually got the, so these are my frequencies. I mean, from the frequency, what I saw actually from where I calculated these percentages, I actually predicted this workforce participation rate with, I sort of created a functional form. Okay. This functional form we are just going to see, we are going to talk about this functional form a little later. So, with this functional form I sort of converted that into a probability. Now, going forward, when I am not familiar about certain outcome, certain results. So, what I do is I sometimes use those functional forms to sort of talk about what could be the workforce participation rate given a certain income, right. So, I do not, so I can sample only a small part, I cannot sample a lot, but then when I cannot sample a lot. So, what I do for the other samples, I can only estimate, I can only predict, and that prediction part comes from this formula. So, I have created a formula. So, I am going from known to unknown. So, this is a journey from known to unknown. Okay. So, how I would write? So, let me actually write down these terms, these are important. So, it is basically from known to unknown, okay, from let us say frequency to some probability with some functional form, right, with functional form, all right. Now, look at this again, let us go back to the Excel sheet. Now, here if you look at the numbers again. So, you had when we had this actual participation. So, that is something you knew, these numbers you get in this part, this is something you already you knew about it, right. But this part, when you are talking about this, this is something you are predicting, right. So, this part is already realized in your sample, you actually see that these numbers are there, but when I am creating this log function or 1 minus 1 by log function, this is 1 by log and these two functions. So, when I create these two functions, I am actually predicting, I no longer am actually getting this data from this actual samples, right. So, this part is called realized, this part is called realized sample. So, this sample has already happened. So, it is realized, and this part is called unrealized. Okay. So, I will write this, So, basically realized and this is unrealized. Okay. This part you observe, right, this is observational and this is theoretical, because I will explain. So, when you talk about a frequency distribution, So, we actually observed that we got the numbers, and that is where from there we sort of constituted the frequency distribution. But when you talk about the probability distribution, we are actually using a formula, right? We are using a formula to actually get the probabilities. Also, in the just in case you are having any question here, you might actually think about this one. Here also you used a formula. We used a classical probability formula, how to constitute, how to calculate the probability, you know. So, basically you divide it by the, you know, all possible outcomes. So, here also you are using this formula to constitute the probability distribution, and that is where basically these two, frequency distribution and probability distribution, are differing. Okay. So, you are sort of using a formula to create basically a new distribution, okay, or basically a theoretical distribution, and that is what you are calling the probability distribution. It is a factual thing. So, you actually see the facts, it is factual, whereas this one what you saw, it is more like, you know, so uncertain, right, or here the chances are involved, or chances are involved. So, this is what you have been talking about. There has to be some chances, you know, which are needed to be there. And also here when I use this formula to create a new distribution. So, this is becoming my potential distribution. Okay. This is the potential distribution. This is a potential distribution, right. So, this phenomena, this is sort of, this is something, you know, like this frequency to probability is known as the double structure of variable. So, one way you have the actual numbers, and in the other way you do not have actual numbers, but you have a potential sort of distribution. Okay. And quite obviously we can say that when I am talking about the potential distribution, I am using a random variable, right. I am using a random variable. But in case I am talking about this frequencies, so when I have already realized the observations, I have already got the numbers. So, they are no longer random variable, they are no longer a random variable. Okay. So, this is something we should sort of keep in mind when we talk about frequency distribution, probability distribution, and from there how we are actually deriving the concept of double structure of variable. Now, you can also think it this way, that you have a formula, right. You have a, so here I have explained how from a set of numbers you are coming down to a formula, right. Now, it can so happen that you have a formula already. Now, perhaps this time you have this formula that you have just derived, and you take this formula to sort of predict the observations about an unknown sample or unknown population, right, which you do not know, from where you have not drawn any sample. Now, in this case also this is a double. So, basically again it is a double structure of variable, because I have a known thing, I have an unknown thing first, and then from there you are going to predict something known. Okay. So, that is also called a double structure of variable. So, usually how we represent, so a random variable x is usually represented as you know, capital X, and all the observations that you may, the distributions that you can constitute, you can, you know, represent these numbers like this and so forth. Whereas, for actual x, when you actually, you know, get the values of the variable, so usually that is represented by small x, and all the observations are represented as small x's. Okay. So, this is a notational thing which you are going to follow. So, that is something we need to remember in case of double structure of variable. So, if I am writing a capital X, so that is a random variable, whereas I am writing a small x, so that means actual values of the variable. So, that is already realized. Okay. So, okay, so this is it. So, this is basically the idea of double structure of variable, and we are going to see you know, time and again we are going to use the concept of double structure of variable in you know, in various cases. We are going to see how the formula, the, you know, which from using which we are actually converting the frequencies into probabilities and so forth. We will learn these, you know, these functions, what we call this, you know how do we really explain these functions. We will learn about estimator. So, these are some of the things we are going to cover in the next few lectures. So, with this we end the discussion about probability distribution and frequency distribution and double structure of variable. Thank you.